Hello, today we are gonna see another sorting algorithm. This one is called MergeSort, and as with all other sorting algorithms, given an array T, we want as input, we want as output the T array ordered. Okay, so behind this algorithm we have two main key ideas. The first one is divide et impera. Basically, this means that we are subdividing a bigger problem into more smaller problem, and we keep going to do this subdividing until we reach the smallest parts, of which there will be a lot. Okay. So this is a philosophy you will, a method, a technique you will see in a lot of algorithms in computer science. Uh, Basically, it is divided in two parts. The descending part, which subdivides the bigger problem into smaller and smaller problems. This is subdividing, subdividing, and the second part that stitches the various smaller problems together and does some work solving the problem. Okay, and this is the doing work part. Okay, so in specific for MergeSort, the subdividing part will be subdividing the given T array into two parts, into two arrays, A and B, and keep going with the subdividing until we reach arrays of length 1. Okay. The doing work part is the merge function in MergeSort. The merge function takes as input two arrays, A and B, and merge them into a third array, C, that is ordered. So both A and B and C must be ordered. An example is this behind. To the array A that contains 2 and 3, and the array B that contains 1 and 4 are merged into an array C that contains 1, 2, 3, and 4. Now, let's see how MergeSort works. So here I prepared on the left an example given an array T of length 4. We are going to subdivide it 3 times, and we will obtain 4 units arrays of length 1. So on the right we have the code. The first part is subdividing, so we need to, when we are doing the first step, we need to create the arrays A and B from the given array T. And so we create, we declare new arrays A and B. Here I drew a cloud because if the given array is length is even, then we can split the input array into two equally length arrays. And if the input array is odd, then the first array will be larger than the second. The first array will be n divided by 2 floor plus 1, and the second array will be n divided by 2 floor. Okay, so you can implement yourself these two functions that fills A and B with the elements of T. And then here the heart of the algorithm. The first part is the pink part with two recursive calls on MergeSort. The first call is the left part of the tree, because we are calling the first MergeSort on A, and A is the left part of the array T, because we subdivided it, and B is the right part. So this is left, this is right. Okay. So we are gonna explore the array like a tree. We're gonna do something like this. We have 4 elements. We subdivide. We take the first half, then we subdivide again until we can't subdivide more than this. So we go back, subdivide. Now we can continue. So we go back, and then we proceed with a second MergeSort call. Okay, so we will build, we will make the recursive calls in this order. Okay, so these are the left and right calls, and as you can see in the example of the left, we are subdividing until we reach the unit arrays. Okay, and we keep on subdividing until the length of the input vector, that is A and B, always more subdivided. So until T is a unit vector. When T is a unit vector, we call the last time the MergeSort. So we will give the next recursive call if we give in this MergeSort, if A is a unit vector, then when we are creating the new A, it will have a size of 0. So it won't enter in the if statement and just return an empty array. Okay, so when we have unit vectors, we merge them. So after we did the first part, that is all this, after we built this tree, we start merging the arrays, the unit vector arrays. As you can see, the unit vector, because they are unit vectors, they are ordered. They have one element. So, okay. So let's see the merge code. So given two ordered arrays, how can we obtain an ordered array that contains all elements of the two given arrays? So how can we obtain C from A and B? Well, I wrote a code for the code for this simple case. Here we just create a C array uh, large enough to contain all elements of A and B, and then we check uh, if the element of A is less than the element of B, um, we write the as first element of C the element of A, and the second element of C the element of B. So we would write this if 2 is less or equal than 1. 2 is not less or equal than is not less or equal than 1, so we will enter in the else statement, and so I will write 1, 2. So as you can see, the element of B into the first index of C and the element of A into the second index of C. Okay. So is this the merge function? This works good for this simple case, but it does not for a more complex case. For example, if we have more than one element. So how can we? So this obviously doesn't work, because if we apply this function, we will obtain 1, 2, and nothing. Okay, and this is not ordered. This does not even contain all elements of A and B. Oh, sorry. Okay. So what we can do is first we create this C, A, and B, this C array as previously, but now we will do something else. We will use some indexes, an E index for the A array, J index for B, and K index for C. And what we want to do is quite similar. We want to check whether A of index I is less or equal than B of index J. Okay, if it is, then the C of K will be equal to A of E, and we will go forward with the E index. So as you can see in the example, I erase the E index, jump forward, okay, and copy the first element. And obviously, if in the else case, so when A of index I is greater than B of index J, we have that C of K is equal to B of J. And every time I do either I move either the index E or the index J, I also move the index K. So when I moved E, I moved also K. So now the first cycle I moved E. Now I check if 3 is less or equal than 2. No. So we enter in the else case. And so C of K is equal to B of J. So this 2, I copy this 2 here, and I move J, and I move K. Okay. So how long do I have to keep doing this? Until I hit a wall. So now this is if I go forward another step, I will copy here 3, and E will be out of bounds. Okay, and this seems okay. Now we are at the last element, but now what are we confronting? We are confronting an element A of 2, but 2 is out of bounds, is less or equal than B of 1. Okay, B of 1 is equal to 4. Yes, it is this element. But we can't compare A of 2 with 4, because A of 2 is out of bounds. We should just copy 4 in the last position. So we will keep doing this while we hit a wall. Okay, so let's try to modify the previous code. So here, when A of E is less or equal to B of J, then C of K is equal to A of E, then E++. Otherwise, no, I should cancel these two. Otherwise, C of K is equal to B of J and J++, and then K++. Okay, and this should be repeated for a number of times while with a wall. Okay, so what is this eta wall? If E, while if E is greater than or equal than the array length, if E is greater or equal than A, I should stop. So while E is less than A dot length and J is less than B dot length, I should keep going. I should keep going with this code. So let's make a better indentation here. Okay. So I go on until I hit a wall. Okay. When I hit a wall, what do I want to do? I want to copy the rest of the array onto of either A or B onto the remaining position of C. So when A or B hit a wall, I know that either A or B is finished. I just need to copy from the other array the rest of the elements. And because the B and A are both ordered, I don't need to check nothing else. I just need to copy the rest of the elements. So what are we going to do? We are going first to copy the rest of the elements from the A array. So we will say while we hit a wall, so if we already hit a wall, we won't even enter in this cycle. But if we hit a wall with B, now with this cycle, we are gonna copy every element of A, every remaining element of A into C. And so C of K is equal to A of E simply. And yes, of course, E++, K++. And for the remaining elements in the B array, in the case that the collision with the wall happened with the A array, we will keep copying while J is less than B dot length. In this case, C of K is equal to B of J and simply J++ and K++. and at the end we will be returning the array, the merged array. See. Okay, so now this works. Okay, now let's make a final example, working example of MergeSort. So here I prepared an ordered array. We are, as you can see, subdividing the array. And then after we subdivided it and we got to the unit vector parts, we are going to apply MergeSort. So we are going to merge 5 and 6. We already saw that it works. It works with unit vectors, so 5 and 6. Then we merge 5 and 6 with 4. And here we do merge 4, 5, 6. Then we merge these two. Then we merge these two. And at the end we merge these. These are all ordered arrays. At the end we merge the last two arrays and we get an ordered array. So just to be clear, let's see if this algorithm works, the merge algorithm works with 1, 2, 3, 4, 5, 6. Sorry. Well, we have the E and the J indexes. This is the A and B array, and this is the C array. So, is 1 less or equal than 4? It is. So, copy here 1, advance both E and K. Is 2 less or equal than 4? It is. Same thing. Copy and advance. Is 3 less or equal than 4? Copy and advance. Oh, sorry. You don't delete the item from the copy and advance. Okay, so now we hit a wall. So here we were inside the first while loop. We hit a wall. So we go inside, we try to go inside the second while loop. But the second while loop asks you if E is less than A dot length. So E is equal 3 in this case, if 3 is less than 3. No. So we don't enter the second loop. And finally, for the third loop, it asks, it checks if J is less than B dot left. B dot left is 3. J is 0, so if 0 is less than 3, yes. So here we are inside the third loop. And simply we copy. The elements, and simply we do this. So we have 4, 5, 6. And this is how MergeSort works. Finally, I confess to you that I cheated a bit, and it's up to you to optimize. I cheated a bit because the complexity function I wrote earlier, it's for the optimized version of the MergeSort. The algorithm you saw, its complexity is this, and this complexity, if you do the calculations, result to be n squared. But mm, don't uh, don't be scared. This wasn't all useless. The optimized version of MergeSort is almost equal. Uh, the the problem was that the constant, previously here we had one cost, okay, but the algorithm you already saw, one on the right, uh, doesn't have a constant cost when n is equal 0, because I fill up a and b, and given that a length is n divided by 2, and b length is n divided by 2, we have n, that is theta of n. Okay, so we don't have a constant cost. So in the end, we end up with if you do the calculation, you end up with n squared cost. If we get rid of the this theta of n, and we turn it into a theta of 1, a constant cost, then the cost is the cost you saw, n log n. How do we do this? Okay, here I give you some suggestions. This is the MergeSort optimized. You have a first column MergeSort, in which you give all the input, just the array, and then you call an helper function, MergeSortRec, giving as input the array and the first and last indexes, and then you simply return the stuff, the array that MergeSortRec returns. That is the array ordered. So MergeSortRec should return the ordered array, and it does. Okay, sorry, here I made a mistake. You don't need okay, OneNote doesn't want me to modify, so I just will do this. Okay, you don't need to create new arrays. Okay, this function, it's much simpler. You don't need to create anything. You just use the array t and do the swaps inside t. So in the first MergeSort, I'm passing the left part of the array. So if I passed as input an array t with indexes start and end, now the left part is start start 2 and divided by 2, and the right part is n divided by 2 plus 1 to end. Okay, and this is the right and left. So we don't really split or create new arrays. We just tell the algorithm on what part it should work. And so The only thing you need to really modify, and that I didn't provide to you, is the merge function. Now the merge function takes as input not two arrays, but the original array and the part of the array in which merge has to work. So I gave you an example on the right. We have, if you are given an array T of length 4 like this, and start is equal to 2, end is equal to 3, that means you have to work on this part of the array. What the algorithm does is, instead of creating, no, you didn't create A and B in merge, but instead of needing a two arrays A and B, you just work on this part. So you put the E array on the start. So E it's equal to start. Okay, and then J is equal to end minus start divided by 2. And look if you need to adjust, or there is always the same rule if n is odd or is even. You always need to look for these things, but the important thing is that you place the indexes in these positions based on the start and indexes. You initialize E and J, and then you proceed in the same way. So here uh, you do like this, J. Okay, so copy and then E. So you also need to modify the conditions for the wall, but these are not heavy modifications. You can do it, and then this is the real MergeSort, and this has complexity of n log n.